So good morning. Thank you for joining us for the second of our webinars that we're calling Sharpen Your Dairy Skills as we Flatten the Curve. Hope everyone out there is doing all right in this crazy time. This morning, I'm really pleased to have our first presentation from Dr. Angel Abuelo. So this morning, Angel is going to share with us some sort of newer research on immunity in calves and some of the work he's doing. So Angel, thanks for being a part of this.
Thank you, Barry. I'm very pleased to be with you all this morning. And yeah, so as Dr. Bradford was mentioning, like my goal for like this kind of like 25 minutes is to just go over some of the new research on ways to modulate or improve the immune response in calves. Obviously, this is not going to include all the potential ways or alternatives to modulate immune response in calves. So there are like different ways that unfortunately we're going to have to lift out, but hopefully it will give you an overview of some of like the new research and some of the work that I and others have been doing in this area. So the outline for like this short presentation is really just to kind of like summarize again, like why it's important, why should we care about neonatal calf diseases, and then put everyone back together into what like the basics of immunology in calves and how their immune system works and how it's somewhat different from what we see in adult animals, and then go into the different ways of research that we are doing to see how we can improve those immune responses. So as I was mentioning, like neonatal calf diseases are really important. Like the data from the last NAMS report still puts morbidity kind of like 33%. So it's kind of like 1/3 of the heifers born in the US would experience some disease during the pre-weaned period, and mortality is about like 6%. And this is mainly due to infectious diseases such as diarrhea or pneumonia. And yeah, as you can see, like those a major contributing factor for those infectious diseases is like the inability of the immune system of the calves to mount an effective immune response against those pathogens. Also really important to remember is that rearing costs usually represent 15 to 20% of total production costs. I know that those estimates are somewhat old. As you can see, like that research was done in the early 90s. So it will be interesting to see what it represents right now. And obviously it's going to depend on every farm. But still, it's a significant percentage of the costs associated with milk production. And the evidence is that reflects the fact that if a calf gets sick during this neonatal phase, that has a lifelong impact on their productivity and health status. So if a calf gets pneumonia or diarrhea when they become a heifer or a productive member of the society of the milking herd, then their productivity is going to be affected and the risk for subsequent disease is going to be increased. So it's also something to bear in mind. Then when we talk about immunology in calves, we always have to look at it from like the two perspectives of passive immunity, which is that is transferred from the dam to the calf, primarily through colostrum, because the placenta of ruminants does not allow for transfer of immunoglobulins in utero, and then the active immunity, which is the protection that's conferred by the animal's own immune system. For the today, we are going to focus primarily on active immunity, on how we can improve the responses of the immune system of the calves, but bearing in mind that management and colostrum is paramount, it's really important. So there's not really like a magic bullet that's going to correct or improve poor management. So yeah, colostrum is really, really important. We are just not focusing it right now. I'm just leaving there the link and the QR code for some of the colostrum management guidelines that the dairy team at MSU Extension has put together, some like more like the updated information. So if you're interested in that, please read and reach out if you have any questions. But yeah, so we are going to focus primarily for this talk on the active immunity side. And we always, when we talk about immunology or the immune response, we kind of have tried to put the immune responses into different boxes, and they're like different classifications. One of them is kind of like we talk about innate immunity, which is like the first responders, or it's a generic response to when the immune system faces a pathogen, but it has no long-acting response. It's a really quick response, but it kind of like reacts the same way, whether it's an E. coli or a salmonella. So it's really non-specific. And on the other side, we have like the acquired immunity, which is specific to the pathogens. And it does have a memory, but it requires time to develop. And then both innate and acquired immunity are going to have both cell-mediated factors and, well, what is called like humoral factors, or more like soluble factors. So again, innate and acquired, both cell-mediated and humoral in each of them. And again, we try to see everything in different boxes, but they really interact among each other. So it's really important to know. So like the phagocytes, which are like the neutrophils, macrophages, all those cell-mediated components of innate immune systems do interact with the lymphocytes. So we kind of like see it in different boxes, but when they kind of like act synergistically when facing a pathogen. But for the purpose of kind of having a clear picture, we still have it that way. So now talking about the newborn calf and their immune system. So in theory, unless the calf has been infected in utero, when a calf, when it's born, has no or non-detectable concentrations of antibodies or immunoglobulins in serum. That's why the transfer of passive immunity through colostrum is really important. So, okay, so a calf is being born with no antibodies. Then other issues that we see on neonatal immune systems is that the activity of the complement, which is the humoral component of the innate immune response, it's also lower than adults, and the cell functions of those immune cells is also decreased compared to adults. And it has been shown for like neutrophils or macrophages, like those phagocytes or first responders, but also for other antigen present in cells and B and T lymphocytes. What is important to remember is that calves do have an immune system. So they have like the immune cell machinery of a mature immune system at birth, but that immune system is just naive and usually in a quiescence state. And the development of the immune system really begins when the calf is in utero. So when the development of the thymus, or where the development of the T cells takes place, it's already evident at 40 days of gestation. So when we are already doing like preg testing and see like something that's about like 2 centimeters in length, they are already starting to develop their own immune system. So it is not true that calves are born without an immune system. It's just that their immune system has not been primed and it's not strong enough, if we want to say it these days. And we also have learned from different infections, from different viruses, particularly bovine diarrhea virus, that the fetuses can respond to some virus as early as 70 days of gestation. And by the third trimester, the calf can respond to many different infections. And if that infection takes place, that's when the calves would have antibodies at birth before they ingest colostrum. So they have antibodies that they generated themselves. And another thing to consider is that within like the development of the immune system in the fetus, the biggest expansion of immune cells takes place during the last month of gestation. Something that I became interested on, it was like, well, if all of those that immune development takes place in utero, where they are really exposed to some extent to the same factors of their dams, how that has all that kind of like maternal stress or effects in the utero affect their immune responses. So that's one of like the studies that one of my veterinary students did for her summer project, in which we evaluated the effect of metabolic stress, which we usually define as a combination of excessive lipid mobilization, inflammatory and immune dysregulation, and oxidative stress, which is like the imbalance between pro and antioxidants, or like free radicals and oxidative damage to cells. How that we know that happens in cows when they transition, so when they, even like during the dry period. So how would that we know that affects the immune responses of cows, whether that can have an effect on the development of the calf during late gestation. And this was like a really preliminary study, but what we found was that calves that were born to cows that experienced more, we measure oxidative stress through an indirect measure, so which is kind of like this oxidant status index. But so calves that were born to cows with a higher values of oxidant status, so that they have a higher proportion of free radicals to antioxidant defenses, had lower birth weights and lower body weights throughout the first 4 months of life. And the same for cows that mobilized more NEFAs during the last month of gestation. So calves that were born to cows that had more lipid mobilization had lower birth weights, and those lower birth rates were maintained at least throughout the first month of life. We did not find any difference on average daily gain. So that means that it's not really a compensatory growth, at least during the first 4 months of life, 4 weeks, sorry, of life in those calves. So yes, it does have an effect, at least on the development of the calves. And we also try to assess their the immune responses of the calves. So since this was a preliminary study, the only thing that we just did was kind of like an ex vivo stimulation assay. So we collected whole blood from the calves, kind of like faked an infection in the blood, and see how that how those cells responded. And we measured it through like the release of TNF alpha, which is kind of like a pro-inflammatory cytokine. And what we saw was that calves that were born with cows that experienced more oxidative stress had less robust responses to that stimulus, as you can see by the black bars. And the same results were found for calves that were born to cows that experienced higher degree of inflammation during the last month of gestation. So it seems that yes, the status of the dam during that period, during the dry period, is going to affect the immune responses of the calves. Whether that effect has enough entity to actually affect disease susceptibility is something that we still are trying to find out. So we know that their immune cells are not responding as robust, but whether that's protective, that difference is protective enough for disease, it is something that we are still determining right now. And in fact, that's something of what my lab is currently working on, is to study really the clinical impact of that late gestation metabolic stress. So we were able to find something measuring in the lab. Now does it translate to improve health in the calves? And another of the studies that we are currently still running, despite all the COVID-19 issues, thankfully, is trying to study the effect of different strategies. In this case, we are doing a nutritional intervention to decrease oxidative stress, try and see how that's going to affect the immune responses of the calves. Another important, well, as I mentioned before, the innate immune system of the calves is also immature at birth. And looking at neutrophils, which are some of like the cells that first would respond to an infection. So we know that the oxidative burst, which is one of the ways neutrophils kill bacteria, is reduced during the first week of age, and the activity of metalloperoxidase, which is also another way through what neutrophils kill bacteria, it's also reduced. And those levels do not really reach like the levels of adults until puberty. So it takes significantly long time for the innate immune system to actually work as effectively as in an adult cow. So looking at neutrophils, one of the factors that has been studied in neutrophils is like the use of colony stimulating factors, which are naturally produced cytokines that stimulate the production of neutrophils and also improve their function. And we were interested in that because there is a drug that is approved for improving neutrophil function in transition dairy cows, which is it's a colony stimulating factor label in Restor from Elanco. And we were wondering whether, okay, has been approved for cows that have neutrophil dysfunction around calving, but calves also have decreased immune function, neutrophil function. So we were wondering whether that drug could also be potentially have a positive effect on calves. And at the same time, probably that we started with our study that I'm going to talk in the next slide. There's another group from Brazil that actually administer the drug, which is like this pegbobigastrem, to 10-day-old calves. And they only measure population of cells, not really their function, but they saw that after the administration of this drug to the calves, they saw an increase in the number of phagocytes in those calves. So yes, it does increase the number of neutrophils. However, what we were really interested was about like the function, not necessarily the numbers, because as I mentioned before, calves are born with the immune cell machinery is their function, which is not optimal. So we really were more interested in see whether it can improve the function rather than just numbers. And when we think about like the different functions or ways by which neutrophils can kill bacteria, that's what I have here in like this kind of like graphical representation. So when neutrophils are exposed to bacteria, one of the things that they do is first they engulf the bacteria, which is what it's called like the phagocytosis, and then they would kill those bacteria either through like what's called like the oxidative or respiratory burst, in which is like they just kill the bacteria through an overload of free radicals or reactive oxygen species. They will also use like degranulation, so they accumulate myeloperoxidase, which is also a molecule that will produce free radicals to kill that bacteria. And then lastly, it's what it's called like the netosis, or the formation of neutrophil extracellular traps, which is when the neutrophils are about to die, they kind of like not really explode, but they release their DNA and different proteins and form kind of like these threads that then they will trap the bacteria in there. So those kind of like the main microbacterial functions of neutrophils. So we wanted to explore whether using colony stimulating factors, we could improve those microbacterial functions in neonatal calves. And rather than going first to the animal, we decided to run an in vitro study in which we isolated the neutrophils from 2 to 3 day old calves, and we kind of then treated them with colony stimulating factors in vivo, and we measure the activity or those microbacterial functions that I was mentioning before. And interestingly, what we found was that, well, you can see here on the blue bars are the neonatal calves. We use for comparison also neutrophils from mid-lactating cows, so that we have like kind of like a reference for what a mature immune system how a mature immune system will respond. So that's what we compare. So as you can see here, like calves always have like a lower values of those functions than cows. But what it was really interesting, for example, looking here at the phagocytosis, is that, okay, at concentration of colony stimulating factor 0, that was our control, the phagocytic capacity of neutrophils from newborn cows were lower. However, and regardless of the concentration of the colony factor use, significantly increased, and it actually increased to levels that were comparable to those of a mature cow that had not been exposed to the colony stimulating factors. So for the release of myeloperoxidase or the degranulation and phagocytosis, yes, colony stimulating factors had improved those functions, and in both cases to levels comparable to a mature cow. However, we were not able to identify difference on the respiratory burst capacity or the capacity to form extracellular traps. So we did see some effects on, again, this was kind of like a preliminary in vitro study in some of those key microvesicular functions, but not in all of them. But this still suggests that we probably can explore further and now see whether that in the calf would have an effect in terms of reducing disease risk. Another really interesting aspect that I'm passionate about, probably because it was like what I concentrated in my PhD on, was its oxidative stress. And oxidative stress, it's usually like defined as, like, again, the balance between the total amount of pro-oxidants, some of which are free radicals, and we usually call them like reactive oxygen species and nitrogen species, and it's like the proportion of those against antioxidants. There's kind of like a balance between free radicals and the defense capabilities of the antioxidant systems in the body or the cell. And that's usually referred to oxidant status or redox balance. And when there is an imbalance, when the production of pro-oxidants or accumulation of pro-oxidants overwhelms the capacity of antioxidants, that can lead to oxidative damage to macromolecules that would impair the function of cells or different tissues. And we know from humans and research that has been done in adult cows that oxidative stress affects the function of immune cells. So they decrease the immune cells. And there's also evidence in cows and in humans that it's also linked to an increase in the risk for disease. However, there's not really any data available in calves, but one of like the early studies that were done about trying to characterize oxidative stress in calves, that I kind of like, it was like a summer project for a student that, and it was like really interesting because it was around the time that I was finishing up my PhD, and I think that I had these samples analyzed 4 times because at the beginning I wasn't believing them. So this, like the oxygen status index, again, to interpret it, the higher the value, the more pro-oxidants to antioxidants, or the higher indirect oxidative stress. And what we found, like those values, so what is represented by this gray dash line were the max values that I was seeing in transition cattle during my PhD. And as you can see here, throughout the first month of life, calves had higher values, which at the beginning didn't really make much sense to me. It was like, how is it possible that calves have more or higher values of oxidative stress than transition cows, that we know that they do experience oxidative stress? And then digging into the literature, just reading, okay, well, if we're feeding like milk replacer and things like that, we usually do not balance as well the amount of antioxidants and vitamins and things like that in the diet of newborn calves. But they are also exposed to high metabolic demands if they are growing as they should. So it was really interesting to see, okay, what are really the effects of this increased period of oxidative stress in newborn calves? How is that affecting their immune responses, since we know that that affects the immune responses in other animals? And this is, again, something that also my lab is working on right now. So we know that lymphocytes, which are our acquired immune system cells that actually would be useful both for T cells and B cells, so both humoral and cell-mediated immunity, when they are exposed to an oxidative challenge, as in this case, we have like here, like different changes of their apoptosis is going to increase, so they are going to die faster, to respond to stimulus it's going to decrease, their capacity to proliferate is also going to decrease, their capacity to synthesize immunoglobulins is going to also decrease. And as you can see, many of those functions are essential if we want the vaccines that we are using in those calves to work. So this is something that one of my PhD students is working on right now. And again, we are starting first in vitro. And what we did here is like we isolated PBMCs or immune cells from blood from calves that were 4 to 5 days old. And we have like an in vitro oxidative stress model So what we do is like we add to the media of those cells this AAPH, which is a generator of free radicals. And we have like the concentration titrated so that we know that the cells under those conditions are oxidatively damaged, but their viability is still high. So they're still alive, but oxidatively damaged. And then we kind of like expose them to a bovine herpes virus 1 challenge. And here you can see that the PBNCs that were isolated that were exposed to this virus were able to produce a considerable amount of herpes virus specific antibodies, but that capacity decreased under conditions of oxidative stress. So yes, also in calves that are exposed to oxidative stress, their capacity to synthesize immunoglobulins specific to the pathogens that they are facing is decreased. And that's also the case for the activation of both regulatory and cytotoxic T cells after viral exposure. So in summary, yes, it seems that oxidative stress during this period is negatively impacting the capacity of calves to mount an immune response. So what we are trying to see now is like, okay, what would be like the ideal or a good combination of different antioxidants that we could use in these calves to improve their immune responses, and then move on to in vivo trials in which we will assess that in the live animals. And when we think about antioxidants and how we can supplement them, probably we kind of have that somewhat figured out, although not perfectly tweaked in adult cows. But if we think about, okay, can we supplement the cow so that the calves would be born with a better antioxidant capacity? So maternal supplementation with antioxidants or during gestation, it's very common in humans. And we know that if we supplement the cows during the dry period, that's going to transfer to the calf. But we have to remember that the placenta of ruminants will limit which antioxidants are transferred. For example, selenium is transferred via the placenta, but other vitamins, for example, are not. And it's also important to remember that we cannot just go and feed whatever we want, because excessive supplementation during late pregnancy has been linked in some studies with fresh cow disease. So it's kind of like a fine balance between how much it's beneficial and when it starts becoming harmful. And it has also been linked to the stillbirths in humans. So probably the potential for that to also happen in cows, and probably Dr. Brackford could hypothesize how that could be linked through decreasing different inflammatory pathways that are needed for parturition. Another common practice that is done a lot of times is the supplementation of calves. And at many farms now supplement calves at birth, either with vitamin E and selenium or different minerals. However, it's like some research that shows that probably calves need far more support than that. That's good, but sometimes it's just what it's needed to counteract the oxidative challenge that birth is. And some studies have shown that that's probably sufficient or improves the antioxidant status for just about a week. So probably we need to supplement more those calves. And like some other like research that has been done in the last years show that, for example, the parental supplementation with trace minerals at 3 and 30 days of age improve the neutrophil function in calves, and also some antioxidant capacity, and decrease the morbidity in those calves. And when calves were supplemented again with the same trace mineral complex with a viral vaccine at a month of age, they showed an improved cell-mediated immune response and some improvements on the pathology level on that challenge. A really interesting study that was published late last year, and this was a study from New Zealand that enrolled almost 1,000 calves in different farms, showed that supplementing calves at birth decreased both morbidity and mortality significantly. However, as you can see, like the values of morbidity, like on the control group, are about like 15% for morbidity and 12% for mortality. So they're relatively high, and in those cases, usually an intervention it will be easier to find an effect on the decrease. So it might not work on every single farm. And as I mentioned before, like again, management is key in those situations. So summarizing the antioxidant supplementation for calves, right now, we don't have guidelines for what should be like the adequate value for optimized performance in calves. But we have to be careful right now with supplementing above levels that have been deemed safe by the literature or like the scientific evidence. A, because there are like some potential adverse effects of eating excessive antioxidants, and B, because some of those micronutrients with antioxidants capacity that we regularly use are linked to toxicity, such as selenium. And as I mentioned before, selenium is transferred via the placenta, so we have to somewhat be careful, because if we are already supplementing the calves with selenium and that gets transferred through the placenta to the calf, and then we over supplement with selenium the calves, then the risk for selenium toxicosis is high, and it would be high on those animals. So maybe we need to use other micronutrients that also have antioxidant capacity. And the last thing that I wanted to talk about with regards to modulation of the immune response is vaccination, because it has been somewhat controversial, the use of parenteral vaccines in the face of maternal antibodies, and that's because it was traditionally associated with a failure to seroconvert, or to show an increase in the titers of antibodies after vaccination. However, now we know that's not a good indicator that yes, there is no an increase in the antibody response following vaccination in face of maternal antibodies, but there is an increase on the T cell response. So, okay, we don't have that humoral response, but we still have an increase in the T cell response. And that's when we think about like signs of disease, and this was a challenge model, we can see that it's actually like protective. So vaccination in face of maternal antibodies it's possible. It's just calves would not seroconvert. However, it's true that the magnitude of the response is going to be linked to the amount of bacillus transfer antibodies. So it's something that needs to be considered on a farm-to-farm basis. And yes, probably all of you are thinking, okay, we are just using intranasal vaccines to overcome that maternal antibody interference. And it's really good for particularly like for respiratory pathogens, because we are creating localized immunity in the port of entry for those pathogens. And yes, it might be superior to injectable vaccination. However, some of the earlier studies shown that duration of immunity might be lower than parenteral vaccines. And in some studies, they show that that's only like probably a few weeks. So the increased concentration of, in this case, immunoglobulin A in the mucosal surface might just be shorter in time than other ways. And this is, again, a really recent study from this year from the group at South Dakota University, in which they vaccinated in face of maternal antibodies using a modified live vaccine, and all these calves have adequate a passive transfer of passive immunity, so they did not have failure of passive transfer. And the interesting part was that then they did a challenge with syncytial virus, and you can see here that the vaccinated group shed less viral particles than the unvaccinated ones. And interestingly also, that parenteral vaccination with a modified live vaccine actually increased mucosal immunity in those calves. So the concentration of immunoglobulin A in the nasal secretions was also higher on the vaccinated group. So yes, we can also elucidate a mucosal immune response by the use of parenteral vaccines, even in the face of maternal antibodies. And with that, I just want to summarize right quick that, again, the immune system of calves starts developing in utero, so dry cow management is important, and we need to take into account that we are not only preparing the cows for freshening, but also the calves that they are carrying. Calves do have an immune system at birth, but it's immature and naive. It's our job to actually care for it. And it seems that immunomodulation in newborn calves is possible, but yes, probably further research that includes head outcomes, it's needed, because it's easier to find like an effect on an assay in the lab, but whether that translates to decrease morbidity or decrease mortality, it's a different story, and many studies have not focused on that. And again, vaccination in face of maternal antibodies, it's possible, and mucosal immunity can be induced by both intranasal and parenteral vaccination. However, as I mentioned, this study just came out a couple of months ago, but I think that still would be interesting to see a head-to-head comparison regarding the protection capacity. So we know that we can produce some mucosal response, but whether one way or the other it's better at protecting against disease, it's still to be determined. And with that, I would just like to thank you everyone for your attention. And before I have times for questions, I just want to quickly remind you, if you haven't received an email already, that we are already organizing the Michigan Dairy Health Symposium for next year, which will be on March 11th, and it's going to focus on calf health. So I hope to see you all there as well. And with that, I don't know if we have time for questions, Dr. Brackford.
Thanks, Dr. Boyle. Great job. Really interesting stuff. So I'll just remind or encourage people who are on this webinar to use the chat function in YouTube to send any questions. We're a little bit long on this presentation, so I'm just going to throw one quick question at you, Angel. You've been on a lot of farms in the Great Lakes region, and I know this answer would be specific to farm, but if you had to cast a broad general net and say probably what's the #1 thing that the typical farm could do that would be likely to improve immunity or health of calves, what would you say?
Oh God, that's a really tough question. And yeah, it's definitely going to depend a lot on, it's really farm dependent. Yeah, I mean, obviously colostrum is really important, but when you have that, a lot of times it's, I mean, vaccination, again, it's really farm dependent. That's a tough question to see that in general. Nutrition of the calves is also really important. This is something that I didn't touch on, and I have seen like several farms that probably could do a better job at feeding their calves. So we need to support also the immune system with nutrition. It's something that really I didn't touch upon today, but if cows didn't have the sufficient nutritional status to mount immune responses, we can do whatever we want. We can give them other stuff to improve their immune responses. They are not going to have sufficient energy for that. We need to remember how fast we want the calves to grow. So if they have to face on top of that an infection, that's going to increase their nutritional demands. So looking at the farms that I've been to, that's probably something that I would say that needs to be tackled first before going into any of these other, you can change your vaccine protocol and try to do other things, but if your underlying nutritional management is not working well, vaccines probably are not going to work as well as they should.
Thanks very much. I knew you could handle a tough question, so well done. Well, thanks again for presenting that for us, Dr. Abuelo. And I think everybody in the audience knows they can get a hold of you if they have questions, and I think you'd be a great resource.